We are starting the standard normal calculations. What's that? All right. First paragraph talks about if we know that the distribution is normal or close enough to normal, and we know what the mean is. In this case, mean is mu. And we can always calculate the percentage of data between two values. Well, we've already done that with the empirical rule, haven't we? Now we're going to do it looking at the z-scores by hand. So example 6. Could I have a reader, please?
I got you, sir.
I'm waiting.
Example 6. The height of American man is approximately normal with mean of 69 inches. With the mean of 69 inches and standard deviation of 2.5 inches.
So that's just the stem. That's the same problem we've done before. We've already dealt with that curve. Letter A says what percentage of men are over 6 feet tall? So look what happens to this curve. We've done it before. Oh, by the way, when he did it, here are your steps. And I think I did the same steps. Draw a picture. He used a calculator. We drew it. We also had our area to the right. He calculated the z-score. So did we. Then we went to our table. I think he used a table to say, yes, he used the table of standard normal probabilities, and he got the same answer. 11.51%. And he was smart enough to subtract from 1 at the very beginning, and I missed that step. So, Aaron, nice job. See, I told you. No, really, it is good. Probably somebody else was thinking the same thing, and they just thought they were wrong. Guys, when you think you're wrong, I want you to always be your own advocate and ask yourself, is it possibly I'm wrong, the teacher? Because I didn't do it right. B, what does B say? What's the percentage of men that are under 5 feet 4 inches tall? Oh, not there yet. We've done this before. 69, add 2.5, that was what? Add 2.5 again. And 2.5 one more time. Go the other way, take away 2.5. Take away 2.5. One more time. And letter A is asking us to calculate the area under the curve for anybody over 6 feet tall, greater than 6 feet tall, which he says he was nice enough to tell you that was 72 inches. So when I find it on the curve, where would I put it at? So why is this different than the other problems we did? Is it on the nice, pretty 1 standard deviation, 2 standard deviation? No, it's not. So you can't use the empirical rule. If it was right here, then I could talk about between these two is 68%. If it was right here, I could talk about both of these are between 95%. And we could do all that geometry and subtract from 100, all that, right? But since it's not on the pretty number, I have to rely on the z-score. So we know the formula. Z is the height that I have right now that I'm looking at, 72, minus the mean, 69, divided by 2.5. If someone could finish calculating that. 1.2. Okay, 1.2. I'm going to put 1.20, and you'll see why in a second. But what I want you to realize is this. The normal curve could have been written in terms of z's. 0, 1, 2, 3. -1, -2, and -3. 1.2 belongs right here. Do you see it looks the same as this curve up here, except for the scale at the bottom is different? This 72 right here, this 72, is identical to the z-score of 1.2. Now, I still need to find the area to the right of this. Did we want we wanted greater than 6 feet, right?
Yeah.
So we're going to use the table that I told you to pick up, the Z chart. So let me, we were doing this. So I'm going to show you how we would write this up. I'm going to write it two different ways. The probability that Z is greater than 1.20 is 0.8849. That's how you would write it formally. You could also write it in terms of the height.
So shouldn't it be z is less than 1.20?
No, we went greater than 6 feet.
Yeah, but,
No. Oh,
but the z-scores, isn't this the area?
oh, he's saying he caught him error. Mistake. I'm going to do exactly what Aaron just told. I don't know if I can erase it now. It won't let me. Oh, it will. I'm going to pretend that I knew it all along. The probability that Z is less than 1.20 was 0.8849. The probability that Z is greater than 1.20 is 1 minus 0.8849. Thank you. And I already did this 3 times. I should have gotten it right. Is somebody
0.115.
0.1, why am I doing it twice, 2 decimals? 115, and for kicks, I'll put the extra. Was there another 0? A 1? A 151?
Yes.
All right. So that's approximately 11.51%, right? Now, another way I could write this out, I want you to realize that this is in terms of the Z curve. What if I use the curve at the top? What if I use this curve up here? That's not a Z curve, is it? Is the area the same? Yeah, but watch how I can write it. The probability that the height is greater than 72 inches is. What's the answer to that? Still the same. 11.51%. So here's 2 ways of actually writing the answer. One's in terms of Z, one's in terms of the height that we were talking, but it's the same answer. It just depends on what curve am I looking at. The one that has the scale at the bottom of height, or the one that has the scale at the bottom of the Z-scores. There's no right or wrong answer. You can pick and choose. The answer still was the same. Okay? Let's go back to B. So I'm going to do that problem over here. Same Z curve. This is letter B. I want the height to be less than 5 feet 4 inches. By the way, how many inches is that altogether? 64. So if I just did my normal curve with my heights, if the average is 69, where's 64 at? To the left somewhere over here. Okay? So when I do the Z-score, I bet you it's going to be negative. Z equals to 64 minus 69 divided by 2.5. What is my Z? Negative what? Exactly a negative 2. Well, the beauty of exactly a negative 2 is I think we've done a problem like that before. Won't let me erase it. I'd have to pretend that -1, -2, right there exactly on the line. Could we do this with empirical rule? Yeah, we've done that tail before. What is that tail? Left of -2 standard deviations. It was it 16 or was it? It was 2.5, wasn't it? Because on both sides of from 2 to 2, that stood for 95%, remember? Hello? That means both tails add up to 5. So I'm predicting an answer approximately 2.5%. I say approximately, guys, because the empirical rule is not perfect. It's an approximation, which is why we're using the table now. We won't get the same answer. So let's go to the table, and I'm looking for the probability that z is less than 2.00. Negative 2.00. So which table do I use? The first one? The actual answer is 0.0228. The other day, we said the answer was 0.0250. Obviously, that's not the accurate answer. This is more accurate. And you know what's even better than the table? The calculator. So we went from good, the empirical, better is the table. In a couple of minutes, we'll do the best is the calculator. All right, we've got to finish these though. Yes, yes. Letter C, what's it want? Letter C.
What percentage of men are between 5 feet 5 inches and 6 feet tall?
Between 5 feet and 5 feet 6 inches?
No. 5 foot 5
Oh, 5 feet 5
and 6 foot.
and 6 foot. So the basic picture, 5 foot 5 is how many inches? 65 inches. 6 feet is how many inches? 72. So the average was 69. So 65 must be to the left. And 72 must be to the right. So I'm looking for this area here. All right, guys, by hand, this is a lot of work. I need you to pay attention to this because you're not always going to get to use your calculator when I'm giving you quizzes and tests. Yes, the AP test, you would use the calculator. It's a lot faster. But I have to teach you the concept. Here's what I want you to think of. I want the area that's in between these two goalposts. So first of all, I'm going to think about all the area that's to the left of the 72 inches. This is all the area to the left of 72. And so I'm going to calculate that first. So it looks like this. The probability that the height is less than 72 inches. When I get done with that, I want to subtract the area that's to the left of 65. In other words, what I'm doing is taking the first one and subtract the probability that the height is less than 65. So what I'm doing is taking the yellow area, which is the bigger area, and I'm going to subtract the green area, which is the smaller area. Okay? That's the concept. So to do this, I need two z-scores. I need the z at 72, Then I need the z at 65. You should be able to get this quick, faster than I can get it done. 72 minus 69 divided by 2.5 gets a z-score, and 65 minus 69 divided by 2.5 gets a z-score. Somebody please tell me what the first one is. What's that z-score? Should be positive.
1.2.
1.2. We've already done that one in another problem. The other one?
Negative 1.6.
It should be negative. Negative 1.6. That one we have not done. So, does anybody remember what the area was to the left of 1.2? Remember when I did the answer wrong?
Yeah.
What was that answer?
The one that was wrong and that was right.
The one that was wrong.
0.8849.
0.88. Oh, wrong one. 0.8849 minus. Now 1.6 we've not done yet. Negative 1.6, so I'm going to have to go back to the table and look. Minus 0.0548. The big area minus the small area will give me the middle.
0.8301.
So approximately 83.01% of all American men are between 65 inches and 72 inches. That's what that means. Questions? Was there a part D on this page? My Z table here. Bear with me for 30 seconds. Whoop. It's not go. Oh. I don't see it yet. Oh, there it is. It looks like that. Notice your first page. Notice these Z's. Look at them. Tell me about it. They're all what?
Negative.
Why are they all negative? Look where they are.
Left side.
They're on the left. There you go. They're all over here. They're all to the left of 0. And notice the area that we're talking about. It's to the left. See the area to the left? Look at every single one of these values here. Just look at any of them. Whoop, didn't want to stay. 0.0040. That stood for 0.4%. If I found it there. If I go farther down the table, I'll just grab this one over here. That's 4286, 40, almost 43%. In the table are the areas that I want. Always measured to the left of the z-score. Always. What z do I have? Well, I have to go over here. Actually, it was 1.20. Remember about the area?
No. On the Z.
The z?
How's your
Negative
negative 0?
0? Oh, there's really no such thing as a negative 0. But, I mean, doesn't matter. Negative 0 is the same as positive 0. He's just being consistent. But see, I could have a negative 0, 0. Notice this. Look at he's asking this. Negative 0.00, he says the area is 50%. Why is that true? If you're at 0, isn't the area to the left 50%? Yes. That's why. He's just being consistent with the table. All right? But we're looking at a positive, caught an error. I'm going to pretend that I didn't make 60. I don't know why I did that. First one. Where do I go? I see it right here. Do I use the first column or second column? First column. What does that answer? 0.0228. First table, the negative. Look how he did it. 1.60 is how much again? 0.0548. So here's how you read it. You go down to 1.2. I found it. This column stands for 1.20. See the 0 here? This stands for 1.21, 1.22, 1.23, and so forth. So I need 1.20. That's the answer. 0.8849.
On the negative side?
Yes.
How does it go all the way to negative 0.0? That number?
You talked just a second ago here, and we ended up getting 0.8849. Notice, because all these z's are positive, this z is past the 0 number. So all this area has to be bigger than 50%. Every one of these answers in this table have to be bigger than 50%. Even if we start at 0, it starts at 50. And then if we go 0.01 is a little more than 50%. That's how you read that. The table always gives you the area to the left. So let me go back to our problem. Good job, Aaron. He's actually right. That answer is less than 6 feet tall. What was I supposed to do? I want this area. So what should I have done? Subtract it from what?
1.
All right, let me go back to my work. There it is. 90% has to be on this table here. Find the closest 0.9000 value you can find. 0.900 what?
Wouldn't it be like 0.0 on the first one and then 0.09?
It has to be looking like this. That's 90. That's 90. But that doesn't mean that's the closest. Don't worry.
9998.
0.998.
At the very, very bottom.
That's too big. Because you're 86 10,000ths away. Can you get closer?
So what are you trying to get close to?
0.9000.
Oh, 0.9.
1.28.
Why 1.28? So here's 1.2, 0, 1, 2, 3, 4, 5, 6, 7, 8.
0.9.
You like this one? That is 3 10,000ths away, guys.
Oh, that's bad.
What was it? Oh, good. That was your phone or something. That's 3 10,000ths away, 0.0003. Is that the closest I'm going to get? All right, so that z is 1.28. Yes or no?
Yes.
So I go back to my problem. Whoop, that's not it. Here's 9.
What
Whoop.
about the very last one that's
Is there a part D on the next page? No, there's not. He actually now, I like what he wrote in the first line. Do you see that? I'm actually going to highlight it because it's so true. Using the table is cumbersome. What does that mean? It's what? It's long. It's boring. It's a lot of work. It's redundant. Yeah. So what we're going to learn now is to use the normal CDF and the inverse norm, which I know you already know that because some of you already turned in the worksheet answers and you did the work with the calculator. And I think I asked you guys, why did you guys choose that method? When I gave you a video that did all of the methods, what was the answer? You figured out right away. in one class setting, all by yourself, you figured out that the empirical rule is too much thought process. The z-table is a lot of work going back and forth to a table. So everybody in the world will use the computer before they use the z-table. But you need to realize that when I first learned statistics, Fred Flintstone and I were together in the same class, and we didn't have calculators. We had our z-tables, they were called Z-rocks. They were on a big stone, and it was etched in stone. Yeah. So you're lucky. But then, they were heavy, but we made Barney Rubble carry them, so it didn't matter. I guess we were kind of bullies in those days. All right, number 7. We're going to use the calculator.
One more Flintstones fun. Give me one more.
One more?
One more Flintstones fun.
One more.
For Carlos's.
All I can say is, when we got done, we went bam, bam.
That rocks.
Yeah. All right, number 7. Another problem. The heights of American men is approximately normal is 69 inches, and the standard deviation is 2.5. Same old problem. Same old problem, same old story. But letter A, 7A says, what percentage of men are between 5 feet and 6 feet tall? So we're going to go to the calculator. Matter of fact, I could probably do this right here. I don't even need a new page. It's really simple. Normal. CDF. By the way, where is that in the calculator? Where is it in the calculator? Second vars, number 2. And we always put in the left. 5 feet. How many inches is that?
6.
And we're going all the way to 6 feet. How many inches is that? Now, since we're describing the normal curve with heights, I have to say comma, average was 69, comma, standard deviation is 2.5. And when I hit enter, magically we have the exact answer with not even any work. But I'm showing my calculator step.
You put what number as the first one?
60, 72, 69, 2.5. Answer is? Point what? 8847? 8848. Not bad, is it? I didn't even draw the picture, but on the AP test, you still would want to draw the picture, guys. You still would want to draw the picture and say 5 feet is here and 6 feet's over here, and you would label that. But we do know the area here is 88%, more than 88%. All right, letter B. What percentage of men are over 6 feet tall? Well, we did that one already, didn't we? We did over 6 feet tall, but it's going to be still a piece of cake with my calculator. Normal. CDF. What's the lowest limit of 6 feet tall? 72. What's the upper limit? Yeah, use a big number, 9999. And you could probably also use, well, 100 might be close to the mean, so you want to be careful. You'd want to go at least 5 standard deviations away and it won't matter. I always just say 9999, and I still have to say 69, 2.5, and that answer gives me, should be the same. No, that was a different one. Wait, did we get the right answer for the other one? Oh, yeah. What's the answer, guys? Hey, Seuss, what's the answer? Where's your calculator? You can't be sitting there anymore if you're not going to be prepared and doing nothing. So I need to see a change. What's the answer? I still didn't hear anybody say it. which is exactly what the calculator there showed, 115. Well, was there another decimal on your calculator?
Yeah.
Another one. I don't know why his didn't show it. Maybe he has his set to 3 decimals. You know you can change your settings to be float, which means decimal numbers but only 3 decimal places? Yeah, but I wouldn't recommend it. If you're going to do that, set it to 4, because your AP Stats needs 4 decimals. All right. C, what percentage of men are under 5 feet 4 inches tall? Under 5 feet 4, that would be less than 64?
Yeah.
Less than? So that would be normal. CDF. What's the lowest limit? Negative. Want to go to negative infinity? Negative 9999, comma, all the way to 64, comma, 69, comma, 2.5. And what is that answer?
0.0228.
See, he rounded it. Is 0.0228. Yeah, he set his calculator to 3. I'm not sure why. Okay. Letter D. What percentage of men are over 5 feet tall? I'm just going to set it up, and you're going to do it yourself. Normal. CDF. Over 5 feet means I do what? 60 to where? 9999, comma 68, comma 2.5. Okay, so,
69, sir. 69.
oh my goodness.
What's your credit?
Maybe. Yeah, I'll give it to you on your next thing. Under 6, and Aaron, you did catch you catched a really bad one. Yeah, I should have said that to you before. Letter E, under 6 feet 2 inches. Normal. CDF, under 6.662 would be what? Negative 9999. Up to where? 74.
Yes.
Oh, it is 74. Then 69. And then 2.5. Sam, Jesus, bring up your papers. Both of you, bring them both. Letter G. That's going to require a little more thought. Give me letter G, please.
How tall must a man
How tall must a man be to
Be in 90th percentile and 99th percentile.
Okay, 90th percentile.
at 99th percentile, sir?
Well, I'll first do this one. How tall must a man be to be there? So as I look at the picture, 90th percentile.
Oh,
This time it's reverse. I already know the percent. I already know that if he is here, he has a height. And this is 90% to the left. Your percentile is the area to the left. So I'm going to do it two ways first. I'm going to first go backwards and not use the inverse norm. I'm going to use your z-table. So I have to do the z-score basically, but I need to know what the z-score is for 90%. So I go back to my table. Z is 1.28, has to be equal to the height minus the average over 2.5. This will actually find the height because this z-score was for z equals to 1.28, which stood for 90% left. Solve that, please. Multiply both sides by 2.5 and then add 69. What is that height? How much? 72.2 inches. Let's use a calculator and double check it. Write this down. This is by hand with the table. This is with a calculator. Inverse norm. Inverse norm says I already know the percent. It's 0.9. Inverse norm. It's second distribs, second bars, number 3. The average again was 69, and the standard deviation is 2.5. If you key that in, it should give us an answer pretty close to 72.2.
Wait, so where'd you put 0.9?
That's the area that I know I need.
Oh, yes. Okay.
Inverse norm goes reversed. 72 point what? Is there another decimal? 20. 20 what? 24. I'm just showing you that there's actually more to the answer than our table could give us. Our table was limited at 1.28. When the calculator does this, it's using a z-score that has more decimals. But we still would have probably left it as this. Probably. All right. This also wanted 99th percentile. What time's the bell ring?
5. Right now, sir. Like right now.
Inverse norm. 0.99. 69. Shh. Sophia, please read the chart there. Make sure the time what it says the bell's going to ring.
At 11:15, and then it's 12:35.
Was there? All right, guys. You have those 2 pages that are stapled, must be finished. And you have a quiz when you come back. I lost my tape.